I'm Malik Suleiman. Oh, I'm Malik Suleiman, a teacher at Mubuti Boys Secondary School, an examiner in mathematics paper 2. Today I'm here to share with you and everybody else a few tips here and there where students lose marks. Mathematics is very easy, but at times we lose marks on due to some small techniques that are left here and there. So we're just here to share. We need to share and get to know exactly at which areas do we lose marks. Not really because you don't know the method or the working, but maybe because of some little instructions that were put in a particular question that was left hanging. Maybe because you are in a hurry, or maybe you didn't read the question completely. So paper 2, basically mathematics, paper 2 work is basically 80% Form 3, Form 4 work, but a smaller percentage of 20% is done in Form 1 and Form 2 syllabus. As compared to paper 1, where we do 80% of Form 1 and Form 2, and 20% Form 3 and Form 4. So I wanted to share with you, I sat down and did some analysis of the past 5 years. I left 2016 because 2016 was a repetition of the other year's exams. I came up with analysis of the topics that have been tested from 2014 up to 2019 that I want to share with you. Okay, that is from 2014 to 2019. Okay, that is what we have. You can look at from 2014 to 2019, there's some topics that have been repeated most of the times. You can look at approximation and errors, for example. 2014 question 1, 2015, 2017. There's some topics that they appear like they are coming almost every year. If you look at SATs, logarithm 2, the one in Form 3. And then angle properties or circle, making the subject of the formula. You can have a look at those particular areas. You notice that most of those topics come from 3 and 4. When it comes to section B, and you can appreciate that even commercial arithmetic, when it is not appreciation, you can see the alternate between appreciation to tax to higher purchase. You can see that 2014 it was appreciation, 2014 higher purchase. Another penalty that can be penalized or can be given in those particular areas if you fail to show your working is what we call omission of work. When you, a very critical step that you are supposed to show in your working and it is skipped. So those are marking codes. M is for method, A for accuracy, and C for the curve. L for the line correctly drawn, and B mark is usually awarded for an included method plus an independent answer. For example, if you are working with angles, you may not have a specific formula for doing that, but if you have the answer, a B mark is awarded. The same applies to construction marks. There's construction questions. If you're asked to construct 6 degrees, for example, or bisect a particular construct a perpendicular bisect of a line, a B mark is awarded because there's no particular formula for that. Those are some of the areas that students make some mistakes. Answers without proof of working, maybe you lifted answers from somewhere else. That's why we insist that you have to show your work as a proof of working to earn that particular mark that we're saying that marks may be awarded for correct working even if the answer is wrong. And then some works become very invisible. Somebody does a lot of work and then it is like shady. The answer is at the top, the working is at the bottom. So you try to arrange your work logically. I'll advise that if you have a page, you divide the page into columns so that when you're through the first column, you go to the next column, to the third column. And then failure to follow instructions. For example, you can be given a question in construction. Use a rule and a pair of compass only. And then you go ahead and measure the angle. In that case, you'll lose that mark for construction. Or sometimes you're asked to use a matrix method to solve a simultaneous equation, but you go ahead and use a different method. For example, you apply elimination method or substitution. Or another question, maybe in commercial arithmetic, you are told to leave your answer to the nearest shilling, and then you go ahead and leave in terms of decimal. Or maybe give your answer to correct 1 decimal place, and then you go ahead and give your answer maybe to 4 significant figures. The same will apply when you're given a scale to use. This applies in scale drawing and also in graphs. You are given a particular scale to use in the y-axis and the x-axis, but you go ahead and use a different scale. In that particular case, you'll lose the marks for that particular work. Now, when you are working especially in three-dimensional geometry, you're supposed to maintain 4 significant figures up to the end. If you must round off, you round off your final answer if the instruction says so. But when working, you must maintain the 4 significant figures up to the answer. I've also written there use of wrong units. In mathematics, a unit may not be very important in giving your answer. We are interested in the value. But if you commit yourself and write the wrong unit, you lose the accuracy marks. For example, if you have to calculate a volume, and you go ahead and give your answer, maybe the answer was 200 centimeters cubed, but you go ahead and write 200 centimeters squared. In that particular case, you lose accuracy mark because you have committed by writing the wrong unit. But if you leave it at 200 without the units, you still score the marks. So you only lose the marks as a result of the wrong unit, only if you commit and write that particular wrong unit. But as we say that in mathematics, we are not very interested in the unit, the units. We pay attention to the value of the one that comes from the working. So those are the areas that I was trying to mention. If you use a different method. In quadratics, you may be asked to use a completing square method to solve a particular question. But you go ahead and use the quadratic formula or refactorize. Or in simultaneous equations, you are asked to use matrix method. And you go ahead and use elimination or substitution. Very interesting in construction. You may construct a triangle, maybe triangle ABC, and then you're told that maybe drop a perpendicular bisector from point C to meet the AB produced. And then the word hence is used. Hence calculate the area. The word hence implies that you're supposed to the word hence implies that you're supposed to use what you have been asked to do up there, because up there you've been asked to drop a particular bisector. So in that particular, the only formula that will be applicable there is a half base multiplied by height. But you'll find that in that particular case, you may construct drop a particular bisector, but you go ahead and use the hero's formula because you have all the sides, or you apply a half A, B sine C to calculate the area of the triangle. So for that part, the construction will be right, but for that particular part of calculating the area, you may not score the marks because the word hence was referring you to, it was a leading statement. Drop a particular bisector hence. Hence implies that you use what you have been asked to do up there. Or the same applies, you can be asked, you can be in a matrix, and then you are told to determine the inverse of the matrix. Hence, find the intersection of those particular, maybe 2 lines. That implies that those 2 lines, you have to solve that particular equation by using the matrix method, not any other method. So the word hence is leading. But if it is said hence or otherwise, in that particular case, you are free to use any other method. But if the word is just hence, that means that you only need to use that particular method that was the preceding method. Now, I've mentioned some penalties that one of them is omission of work. Omission of work is penalized when you fail to show a particular step or a key step in your working. You are usually awarded marks, but you are deducted 1 mark. It is written OW minus 1. The second one is called premature approximation. Like I mentioned that in 3-dimensional geometry, you are supposed to maintain 4 significant figures up to the last answer. If you are supposed to only round off your final answer, again, you are penalized 1 mark. If it was a question of 3 marks, you will penalize 1 mark. So when can I omit work? Let's look at that question. You are told that the length and width of a rectangle measures 60.5 and 12 centimeters respectively. Determine the percentage error in the calculation of its area. That's an example. I just in this particular question, it is awarded 4 marks. You're supposed to get the maximum area, minimum area, and the working area. And the key interesting thing about mathematics is that you are awarded a mark for a particular activity. Like the first 1 mark there is testing. Do you know how to find the area of a rectangle? If yes, if you can multiply length and width, by showing the actual area, which is 60.5 by 12. You're given 1 mark for the method. Then you go to finding the absolute error. Maximum minus minimum divided by 2. That shows that you have the idea of how to get the absolute error. You added another method mark. Now, this student has gone direct to find the percentage error. Of course, we expect that you're supposed to take the 30.85, you divide by the actual, which is 726. That student has done that in a calculator and got the correct answer, which is 4.249. And actually, that is the right answer. So you can see, we didn't see the working for having the absolute error, which is 30.85 over 726, which is the actual area, multiplied by 100. But we have the actual answer, which is 4.249. Again, also to first significant figures. So we award him M1A1, but we subtract OW minus 1 because there was a key step that was left by the student. The student didn't show the working for finding the percentage error, which is the 30.85 was supposed to be over 726 divided by multiplied by 100. So that particular key step is omitted. So that's why we instead of getting the 4 marks, you end up with 3 because of some particular work that's omitted. And it can vary from, it can also change with situations depending on what you are given to do. Now, when it comes to premature approximation, I've picked an example there of a pyramid. You've been asked to find the angle between so of course, if you want to find the if I was to find the angle between the edge CV and the base ABCD, first of all, I have to find the diagonal AC, and the diagonal AC will be 30 squared. That will be OC. The diagram and the working on different pages. So you have to find the diagonal AC divided by 2 so that you end up with the length OC. And then given that so triangle VOC forms a right angle triangle, of which VC will be the hypotenuse and OC will be the base. But in this particular case, it will be the adjacent. Is that right? So we'll pick a particular ratio, trigonometric ratio that combines adjacent and hypotenuse, which is cosine. So this student went ahead and did the same question. But rounded off his answer. Instead of, if you divide 30 squared by 10 squared divided by 2, I think the answer will be 15.81. But the student rounded off to 16. And then went ahead and identified that the cosine of that particular angle that is required is 16 divided by 26. From his working above there, to get 0.6153, you go ahead and find the sine inverse, the cos inverse, which is 52.02. So that particular question, of course, I can see the working. I'll follow through. Instead of 15.81, the student wrote 16. And then you go ahead with the same working. That means that you have prematurely approximated the first value, but you work with the value up to the last answer. So if it was 3 marks, I'll award you M1, A1, M1, M1, A1, but you'll be deducted 1 mark for premature approximation. We expected that in this particular, the first part of OC, you're supposed to maintain 4 significant figures. If you do that, what do you get as your answer? Half of 30 squared and 10 squared. 15 points. So instead of 15.81, the student went ahead and wrote 16, which was a rounded off answer before you go to the answer. So when you go ahead and work with that particular question, with that particular value up to the end, I'll follow through, mark your work because you are doing the right thing. The only mistake you have made is that you have rounded off early than expected. So we award you M1, When you relate cosine of x as 16 over 26, also award you M1. And then the answer is also for significant figures. You also get an A1 answer. But at the end, we check, we say PA minus 1. That is the premature approximation. So we encourage you that when you're doing working, you maintain four significant figures. You must round off, only round off the final answer, depending on the instruction that is given by the examiner. So those are the situations where somebody can lose. I think the comparison between the two. You can look at those comparisons. The one in blue is the correct working that is supposed to use the two marks M1, M1, A1. But the one on the left, you get M1, M1, A1, but OW minus one, because you did some approximation from the first working. Now, this mostly appears in paper 1, inequalities. Inequalities have got inequality symbols. Equal to, less, or equal to, less than, or greater than. But when a student is given that question, some students have got the habit of replacing the inequality signs with equal signs. Now, the moment you change the symbols from inequality to an equal sign, the equation changes. That means that you're now doing a different question from what was given by the examiner. So in that particular area, you will not score any marks. Inequality, most of the inequality questions we award B1. In that particular case, you will be awarded B0, 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 because you have changed the question from inequality to an equation. And then number 2, there are moments you are asked to represent your working of the answer on a number line. Most students do it very well. But when it comes to the intervals between, maybe you draw a number line. That is an example of a question that was, I think that was 2013. So you are given the inequalities. They appear to be very small, but so if I was to solve the first inequality on the left, I've solved the first inequality. The first value of x is greater or equal to 1.5. Then the next is x is less than 5. I think the major reason you also discourage you from this, because you know when you're dividing an equality by, if you divide both sides by negative or multiply by negative, the symbol changes. Like in the first case, you can see it was negative 2x is less or equal to negative 3. But when you divide by negative 2, the inequality is supposed to change to x is greater or equal to positive 1.5. If you are to use equal sign, you'll never see that. But some students are very bright. They use equal signs, but they come up with the same answer, like you can see on the right in blue. So in that particular area, when a student goes ahead, like you can see in blue, he has replaced the inequality symbols with equal signs. Instead of having x minus 5 is less or equal to 3x minus 8, he has used an equal sign. But at the end, he has the right answer, which is x is greater than 1.5, greater or equal to 1.5. Then the next question, again, the next inequality, he also has 3x minus 8 is equal to 2x minus 3. Then, surprisingly, again, he replaces the correct inequality symbol. He has the right answers, but he has replaced, he's working as using equal signs. That means that he has changed the question from inequality to an equation. So in that particular case, you'll be awarded B0, B0, because you changed the question. And then when it comes to representing the solution on a number line, as you can see that I've drawn a number line from 0 to 1 to 2, 3, 4, 5, 6. Now, the interval between 0 and 1, if it is 1 centimeter, between 1 and 2 must also be 1 centimeter, and between 2 to 3 must also be 1 centimeter. Those intervals must be equal. If the intervals are not equal, that means that particular, the mark for representation on the number line will not be awarded. The B1 down there will not be awarded, because the intervals between the 0, 1, 2, 3, 4, 5, 6, if they are not equal, you lose the work for the B mark for the representation of the number, the working on a number line. So that's the key thing you're supposed to remember. And you should never replace inequality symbols with equal signs. And then number 2, on a number line, you pick equal intervals for the number line, that if it is 1 centimeter, you can approximate, have them all as 1 centimeter. If it is 0.5, all of them must be 0.5. But in number B, even on my right, on the one in blue, even if I was to represent that correctly on number line, I'll still not get the work, because it is an answer coming from a wrong working up there. So you can see that the moment you replace the inequality symbols with equal signs, everything is lost. Now, inequalities are also used in linear programming. And linear programming is a question in a particular area that is highly tested again in paper 2, I think almost every year. That's an example of a question that was set in, I think, in 2017. Okay. So that's the person that is represented in that particular area. Now, in this case, you've been given let X represent the number of kilograms of beef and Y represent the number of kilograms of mutton. Now, I want to mention that if that statement was not given and you start doing that question, you must also give that instruction. You may start using the X and the Y, but you have to define what does X mean, what does Y mean, informing inequalities. You may not be penalized for that, but it's important to indicate before you do or before you start representation, you indicate which is for X and which one is for Y. So in that particular case, all you need to remember is there's keywords that are used there. Like the amount of beef must be at least 30 kilograms. When you're given at least, which inequality are supposed to replace? At least. Should be greater or equal, is that right? And that of mutton should be at least 20. So at that particular case, mutton, which is Y, should also be greater or equal to 20. The total mass of beef mutton bought should not exceed 100 kilograms. Should not exceed, that means that less or equal, is that right? Should not exceed or should be a maximum of. And then again, this gentleman has got the amount of money he's supposed to spend should not exceed 43,200 per day. So you take 360 for beef, you multiply by X, 480 by Y. When you add that value should not exceed 43,200 per day. So if that is represented on inequalities, we have the inequalities up there. Now, in forming inequalities, you are not compelled to simplify. You can see the last inequality there. 360x plus 480y is less or equal to 43,200. That mark is awarded at the earliest opportunity that is there. That means that if you are to make any mistake in simplifying, so to get the 3x plus 4y is less or equal to 360, you may not be penalized for that because the first inequality was right. So you are not under any obligation to simplify that particular inequality of 360 plus 480. Though when you simplify, it will be easier to draw the graph. But once we see it at that particular, the earliest stage it is seen, the mark is awarded at that particular age. And then the representation on the graph, as indicated there, we all agree that if the inequality is less or equal to or greater or equal to, we use a continuous line on the graph. Like in this particular example, all of them were greater or equal to or less or equal to. But if one inequality was less than or greater than, we agree that we use dotted lines in those particular areas. That's right. And then you do the shading. The shading is done, you identify the unwanted region and the wanted regions. Now, we notice that most students are able to do up to that particular area. Actually, the first 5 or 6 or 7 marks are always scored by students. The problem comes on the lower part when you are asked to determine make the maximum profit or the minimum profit. The reason for that is most students struggle to draw the objective function line or the search line as we term it. But there's a simpler method that we can use that is accepted in marking. You can pick points. If you need maximum profit, for example, I've put some red marks on those on the margins. of the lines. You will agree that if I was to do for the objective function line, the points should be on the upper region. Is that right? So if you select those upper regions, like the first point I've selected is 40, 60. The next point we have is 50, 50, 50. Is that right? And then we have 60, 40, and then 70, 30. Now, in that particular area, I can decide, because the question is given there. You are given a question on the lower side. That is the question that always gives students problem, because you're able to represent on a graph. But when finding the last 3 marks, it's always a problem. But it should not be something that should give you a problem. Now, once you pick those points, you'll be told that a profit of 50 kilograms on each kilogram of beef, which was on the x-axis, and 60 shillings profit on kilogram of mutton, which was on the y-axis. So if I picked my first point, which is 40, 60, then you multiply 40 by 50, which is the profit for beef, and 60 by 60 is the profit for mutton, you get a value which is 5,600. Then you also do for the next point, which was 50, 50, you get a profit of 5,000. For 60, 40, which is the third point, you get 5,400. And for 70, 30, you get a profit of 5,300. Now, the condition for this is that you must pick a minimum of 3 points when using this particular method, which we encourage that. I think it becomes more simple. It even takes a minimum amount of time when than drawing the objective on the sideline. So once you have tested at least 3 points, the minimum should be 3 that you pick. But among the 3, the correct answer must be among them. So it will be a little bit tricky, but we encourage that you can pick from 4 going onwards. But the maximum will be on the upper region. So from those values that we get of the profit, you notice that the highest value is 5,600. So that means that if you follow that, that shows that the maximum profit can only be got when there was 40 kilograms of beef and 60 kilograms of mutton. And you go ahead and express, write that final answer. That maximum profit is equal to 5,600. Or better still, if I was just in a hurry and I just underlined the 5,600, that was the first value there. If you just underline that 5,600 up there, the marker will be able to see that you have distinguished the 5,600 from the other 3. Is that right? Underlining is a way also, you can also distinguish your answers by underlining those particular areas. So this particular method is acceptable and can save you time, because we notice that in this particular question, when it comes to the last 3 marks, the students always lose marks because most of them struggle to draw the search line, and then they fail to use it appropriately. But you can pick this method of picking points. Of course, if you are to ask minimum point, you go to the lower values of the region. But maximum, you go to the upper part of the region or the values of the region, so that you are able to get the exact maximum profit. But we have said that you must pick at least 3 points. But the correct one must be among them. So we encourage that you can pick from 4, 5. But again, you'll be guided. If the graph was going to the y-axis, if maybe from your representation of the graph, let me go back to the graph. If the value was going, maybe x is equal to 0, you may not necessarily pick that point, because when x is equal to 0, that means that one particular value will not be there. So you can not get a negative or a maximum value from that particular region. So that can really help in finding those, scoring the last 3 marks, because most students always score the first 5 or 7, but the remaining 3 marks on testing the profit, maximum or minimum profit, is always lost. But this particular method gives you a very clear or easy way of getting those particular areas or those marks. Now, the next topic that is highly tested in also in a Form 4 topic is latitude and longitude. This topic only has 2 formulas. When this is along a longitude or along the equator, we call those great circles. And the formula is simple: theta over 360 multiplied by 2 pi r, that is in kilometers, and 60 theta in nautical miles. But if you are getting the distance along a latitude, latitudes, we call them small circles. The formula is again the same. We only add something: theta over 362 pi r cos alpha. That is the distance kilometers. And nautical miles, it is 60 theta cos alpha in nautical miles. The theta in both cases is the difference, either the latitude difference or the longitude difference. And then the alpha there, in that particular case, it is the degree of the latitude along which you are finding the distance. And then in this particular topic, again, if you are given a question that is testing, give the position of a particular point, or a point B or a point A. The position must be given in coordinate form. That means that you have to set the latitude, the longitude. Sorry, you start with the latitude and then you set the longitude. It must always be given in coordinate form. Now, if I take you to the next, how do I know that a point lies along a longitude and lies along a latitude? If you look at point A, 20 degrees north, 56 degrees west, and B is 45 degrees south, 56 degrees west. The common figure there is 56 degrees west. Is that a longitude or latitude? It is a longitude. So that shows you that those two distances, or the points A and B lie along a longitude, and a longitude is a great circle. So you go straight to the formula that we said, theta over 362 pi r. That is simply a way of knowing whether a point lies along a great circle or a small circle. So in that particular case, you know the exact formula to apply. And then in the next point P, 45 degrees south, 25 degrees east. And then the next one, you also have 45 degrees south, 55 degrees east. Now, south is common with the same figure. And east is also common, but different figures. So that implies that those 2 points lie along the same latitude, but different longitudes. So if point lie along the same latitude, then you can see that the latitude is constant. So that implies that the distance between P and Q is a distance along a small circle. So you go for the appropriate formula. The 70 is a result of 125 minus 55. Is that right? And then you can see the cos alpha you're talking about. It is now the 45 degrees south. It is a distance, the latitude along which that particular distance lies. The cos 45 is now the latitude. The one for AB, we got the 65 as a result of adding 20 degrees north and 45 degrees south. We say that when they lie on different ends of the equator, you add to get the angle difference. That's right. But when they lie on the same side, you subtract, like we have seen number in part P, PQ, 125 east, 55 east, you subtract to get the angle difference. I think if you master those two formulas and you're able to establish that, is this a great circle or a small circle? In that particular area, you are good to go in that particular topic. Nothing else that, so long as you can find the angle difference and you are able to establish that which particular method should I apply, you'll be good to go. And in that particular area, you'll score the marks. I picked a particular question there. You are given, that was 2014 paper 2. The shortest distance between 2 points A, B, the coordinates are given there on the surface of the Earth is 8,008 kilometers. Given the radius of the Earth is 6,370 kilometers, determine the position of B. So I picked that for the word position of B. That's why I said that if you're given position, you have to state in terms of coordinates. Now, you can also notice there that we have the 20 west, 20 west. That means that that discriminates that particular question. That means that those points lie along the same longitude. So we go for the formula theta over 362 pi 2 pi r. Now, I need to explain. Most students always confuse the M. If we talk about method mark is awarded not because of writing the formula itself, but using that formula appropriately. That's why I have not written the theta over 362 pi r, but I've just substituted it. That means that the distance between A and B, which is 8,008, should be the same as 40 plus theta. I'm adding the theta because 40 is north and theta is south. Is that right? So the angle difference will be 40 plus theta. You multiply by 2 pi r, you get to 8,008. If you work out that, you get your theta as 72. Theta plus 40 is 72. That means that to get theta, you subtract 40 from 72. And you can see the area where you added, the method mark was the point you substituted the values of the distance, the angle difference that we have, and the radius of the earth given. Then you go on with the marking. The moment you find 72 degrees, we award you A1 for finding the 32 degrees. That is the value of theta. But the last one mark can only be awarded when you clearly state the position of B, which is now 32 degrees south, 20 degrees west. If you reach that point, the point when you have 32 degrees only, you have not got you have only got the value of theta, but you have not got the position. But if you are asked to find the position of the point B, you have to go ahead and find the right interval coordinate, which is 32 degrees south, 20 degrees west. That will enable you to get the full marks in that particular area. Now, the same topic, I picked this because in the same particular area of latitude and longitude, sometimes you can be given a question, you calculate the distance, and then you are given speed. Then, of course, you could be asked, the next question will be asked to find maybe the time, the particular plane reach a particular point. But I picked a simple example for easy understanding. We work with calculators. This is time interpretation. We work with calculators, and most of the time when you find a decimal, especially with the time, most students always confuse the time that they get from the calculator and the actual time they're supposed to record. That's a simple example of a car traveling from a point A to point B. Oh, the distance is omitted there. The distance between A and B is given as 500 kilometers, but the average speed is 80 kilometers. Then you are asked at what time did the vehicle arrive at point B. So to get the time taken, you divide the distance by the speed. And if you work that in your calculator, you get 6.25. Now, we have observed that most students always record that as 6 hours and 25 minutes, which is not right. Now, if you have your calculator and you press 500 divided by 80, you'll get 6.25 displayed. Is that right? The 6.25 is 6.25 hours. Now, if you have a problem converting, because sometimes you may get something like 5.833, instead of struggling to convert that into minutes, there's a particular function in your calculator. If I can, there's a particular function on your calculator above, I think where you have, or below the square root. Below the square root symbol, there's a point you have things like look like colons. If you press that with a 6.25, what do you get? You get 615, is that right? So that's the simplest way of converting the time you get in hours into minutes. Even if you to get 5.833, if you press that, you get the exact hours and minutes. So if you get 6.25 and press that button below the square root sign, you get 6 hours and 15 minutes displayed. So that is a point where most students always lose marks, because most of them go ahead and record the 6 hours and 25 minutes at the correct time, which is not the right to be used. So if you do that again, you now go to the 8 a.m. add the 6 hours 15 minutes. The answer will be 14:15. Now again, in displaying the correct time, if I say 14:15, there should be no colon in between. If you put a colon in between, that is not 24-hour clock system. So if it is 14:15, it is 14 hours. But if it is a 12-hour clock system, you rate 2, then the 2 dots, which is a colon, then 15 p.m. So the time must be very specific. If it is a 24-hour clock system, there's no dots or there are no colons. And if you have the 12-hour clock system, you put the dots and you put the specification. That particular area is the PM. So this is applicable. You can even meet it in the LCM, the question in paper 1 in LCM, when you are told maybe bells take 30 minutes, 20 minutes, or 50. The point you go to find the LCM, and then you divide the LCM by the number of minutes that are required, or by 60. You get a decimal, and then you are supposed to add to get maybe the time that bell will next time rang together or last time rang together. The time interpretation there becomes wrong. Instead of recording the right time, the calculator, you pick the decimals, which will make you lose marks. Now, another topic that is highly tested that we had saved slightly in paper 2 is three-dimensional geometry. Can come in section A or B. The key thing that we have said here is that you work with the values correct to 4 significant figures up to the end, unless otherwise stated. Like this question, you have been instructed to use 4 significant figures. If there was no instruction there, again, go ahead and use 4 significant figures until the last answer. Now, these days, like if you look at that question, calculate the calculate correct to 4 significant figures, and then number A, B, and C are below. That means that the 4 significant figures up there should apply for all your working up to number C. It should not change. But of course, there are some situations where the first figure will be A will be 4 significant figures, B goes to maybe 1 decimal place, C goes to maybe 3 significant figures. You follow through the question. But if the statement is up there, it goes through up to the last part of the question, unless stated otherwise. But from this particular question, the working should be 4 significant figures. Even the answer should be 4 significant figures up to the last value. So you should not ignore or should not round off the values. Again, this is the area that I mentioned that people get booked for premature approximations. Like when I see my number A, if I was to find that length, you get 31.32, again, 4 significant figures. B again, even when you can see the answer for number B is 50.80. Most students will ignore the 0 because they say that 0 after decimal point does not have a meaning. It does, especially in the significant figures. If the 0 was not there, it only qualifies to be 3 significant figures. And then again, you go down there to the last value. If you work out that value, you get 36.19, which again, the value should also be 4 significant figures. So generally in 3-dimensional geometry, maintain the 4 significant figures in your working up to the final answer. Even if I was asked to round off my final answer to 1 decimal place, but my working will still be 4 significant figures up to the end. So that should be taken care of. Now, as you mentioned, there are graphs that are drawn in paper 2, quadratic graphs or cubic curves or trigonometry. Completing the table, most students don't have a problem with that. As you can see, if you work out those values from the calculator, you'll get those values. And we encourage that if you have negative values of x, the best thing to do is to use brackets, especially maybe it was x was -1. I'll have -1 in bracket squared, because if you place without a bracket, the final answer there will not be correct. So filling the table, we have not noticed most of the problem, but these are supposed to be free marks for most of the candidates. Now, when it comes to plotting the graph, again, if you look at that question, on the green provided, draw graph of the equation is given there, and the scale is specified in this particular area. 2 centimeters, 1 unit on the x-axis, and 1 centimeter to represent 1 unit on the y-axis. So this one is that if a scale is given in a graph or in any other question, it must be used. That means that the scale given must be applied. If you fail to use the scale that is given, the S1 mark there will be S0. You'll be penalized for not using the correct scale. Now, the second mark is for plotting. We are only testing your knowledge. Can you transfer what you have on the table to the graph? That's simple. Just plot the values and score the marks. And then on plotting, we encourage that if you are plotting, use just a star, a simple star. We discourage using dots because I may use a very small dot, and in the process of drawing the curve, the dot disappears. But when the examiner is marking your paper, is looking for evidence of plotting. So use just a small cross that is visible. Some use plus signs, but dots we discourage as much as possible, because in the process of drawing the graph, the dot disappears. That means that there'll be no evidence for plotting. The curve may not be smooth as what I have on the computer, but try to draw your curve as smooth as possible so that you awarded the C1 curve. Now, you notice that the C1 curve affects most of the working that comes below the graph. I've mentioned it may not be very perfect, but try as much as possible to have a smooth curve. If the curve has a dent at any particular point and you're supposed to take a reading from that particular area that is that is not very smooth. Those values may not be taken as the correct values. So try as much as possible to draw the correct curve, as smooth curve as you can possibly do. And then this also applies for cubic curves. Now, I'll mention that these particular questions, there's no particular question that will be given where you are expected to draw two curves. So that's what I would say, the S1, P1 for plotting, C1 for the curve. That means that every technique is being tested. Can you plot? Can you use the scale? Can you go ahead and draw the curve? And then number two, when you're taking values, like I'm supposed to read the values, like the next question that will come after the curve, maybe use your curve or use your graph to solve this particular question. Go back to the graph and ask yourself, what is the smallest division that I can see? If I may take you back. The first curve that we have there, if you look at between 0 and 1, we have 10 small squares. That means that we have 10 squares for 1. That means that each small division will be 1 divided by 10, which is 0.1. Is that right? Yes. Now, the problem comes when students try to estimate. Maybe the value may not be exactly 2.1, not 2.2, but is in between 2.1 and 2.2. Then you go ahead and write 2.15. Now, according to the scale that you have on the graph, you may not get the second decimal place. So stick to one decimal place. If it is not very close to 2.1 and very close to 2.2, just write 2.2. The good news is that in this particular area, when we are marking, there's an allowance of 0 plus or minus 0.1. That means that if somebody writes 2.1, still scores, 2.2 still scores. So don't struggle to approximate the second decimal place, which may not be possible from the scale that is given, because when you are taking anything from the graph, we go back to the scale that was used. So if I'm not able to get the 2 decimal places, that means that particular area may not be able to get the accurate marks. So from the graph, you notice that we get the readings. And then when setting the readings, we only be using the X values. That's a quadratic curve. That means that it can be used to solve a quadratic equation. We only insert the values of X. So go to the curve and read the values of X only. You can separate with a comma, or you say X is 0.6 or 3.4. But not as an equation or as a coordinate. If you write 0.6, 3.4, and then you enclose them in a bracket, that shows that that is now not a solution of a quadratic equation, but now a coordinate of a particular point. Again, some students struggle to find the exact coordinates, like they write 0.6, 0, 3.4, 0. Those will be treated as coordinates, not the solutions to the particular equation. I'm referring to this particular area where you have the values of X. You can see there it's 0.6, but if you go ahead and write 0.6, 0, as you can see there, 0.6. After 0.5, you get your value as 0.6, 0. It must also be 0.6 only, not any other part. You don't write the Y coordinate. That's the value I only interested in. And then the second point, again, it is exactly 3 point. I think it is 3.4, not 3.6. Is that right? It is 3.4. So that will also go to the next question. If you are to do that and also represent like the line that has been drawn there, that is another question. The accuracy should also be particularly from the scale that was given there. So like I mentioned, that particular area should apply for quadratic and cubic curves. Like you can also solve that cubic curve. Now I picked this one because of the values that we have there. If you feel that value, those values for y is equal to x cubed plus 3x squared minus 4x minus 12. And then you go ahead and find the values of y. At -3, you notice the value is 0. And at -2, the also value is 0. At 0, the value is -12. And at 1, the value is -12. Now, I picked that one because of the nature of the curve that is supposed to be drawn there. If I was to transfer those values to my graph, you notice that between -3 and -2, all I have is 0 and 0, and nothing in between. This is supposed to be a curve. One option is that you look for the midpoint of -3 and -2, which is -2.5, and feed those values according to the question that you have in your calculator, and find the approximate value for -2.5 to lead you into where the turning point is supposed to be. Because you find that that particular area, most students will draw a flat line there between -3 and -2. They draw a straight line. So if that part becomes very straight, the curve mark will be lost. The same will apply to the point where we have +1 and 0. The point where we have 0 and 1. You can see where you have 0 and 1, the value there is -12 and also -12. Again, that particular point between 0 and 1, you are advised that you use the calculator, find the approximate value for between 0 and 1, the midpoint, the point there is 0.5. Find that exact value and plot it there so that you find the turning point of that particular curve. If you're not able to, you make sure that that becomes a turning point. You draw a curve. But if you make it a straight line or it becomes flat at a particular point, the curve mark will be lost. So those are the few areas. When you are drawing a curve and you find that two particular adjacent or successive points, the values are the same. It's upon you to find the turning point of that particular curve so that the curve turns, so that you're able to get the turning point of that particular curve. So that's the main reason I picked that particular area. And again here, when reading the values, I go also look at the scale. It's relatively the same as what we had there. Between 0 and 1, we have 10 small squares. That means that you can only read a maximum of 1 decimal place from that graph that is drawn there, or from the values that we have. Just like you have seen there, for a cubic curve, the values will now be 3 answers. That was a question that we are asked. Use the curve that we have drawn to solve an equation of maybe x cubed minus 3x squared minus 5x minus 6 equals to 0. So arrange the curve that you have drawn and the equation that is given there. When you subtract, to get a line of y is equal to x minus 6. So you go ahead and draw that line. And then after drawing the line, you read those values where the curve and the line intersect. So look at where the curve and the line intersect. Like you can see the first point is the curve and the line intersect at which point? Are you able to do that coordinate correctly? It is -3.9, is that right? Now the second point is just after 1. It is at 1 point, so it is -1, just before -1. It becomes -0.9, is that right? And the last point is just after 1.7, is that right? That's a perfect example. Between 1.7, between 1.7 and 1.8, is that right? That's what I was thinking about. Some students will struggle to write 1.75. Will not be able to get the 1.75 from that particular area. But you go, if you are to write 1.7, you'll still be right. If you are to write 1.8, you'll still be right. Just as I've indicated that that particular area, you have an allowance of a plus or -1. So don't struggle to find the 2 decimal places if you're not able to get it from the scale that is given. So refer to the scale that you have. If you're able to get the 2 decimal places, it is well and good. If you're not able to, the 1.7 will be right, the 1.8 will still be right. Now, the next area is statistics. Now, if you are asked, there are many questions that can be asked from this particular area. Usually students, the formulas are done in the mathematical tables, so no problem should be there in finding the formulas. But the problem comes when you are asked to draw a cumulative frequency curve or an ogive. Now, the moment you are asked to draw a cumulative frequency curve or to find the median or to find the quartile deviation, the very first mark is always added on the table. Because for you to do all those, you must have got the values for the cumulative frequency. So straight away, go and fill the value for the cumulative frequency, like we have done there in blue. That column for CF will award you 1 mark if you are asked to draw the or to find the median, quartile deviation, or draw a cumulative frequency curve. So the B1, the first 1 mark will be awarded on the table for finding the values of the cumulative frequency. And then number 2, when it comes to this drawing the curve itself, we plot the cumulative frequency on the y-axis and the upper class limits on the x-axis. Again, in that particular question, if a scale is given to be used, you must use it. If are not given, choose a suitable scale to be used. Now, some students struggle to put a break. Mine has no break there, but some people put a break between 0 and the first one, which is 47.5. Acceptable, but not necessary. All you need to do is indicate that on your x-axis, if you look at that there, I've indicated that on my x-axis, the first value I have there is 47.5. But on the y-axis, the first value that I have there is 0. So that directs me that on the y-axis, the first value is 0, the cell starts from 0, and the x-axis, the value starts from 47.5. Now, if you ignore that and write only 0, if the 47.5 was not there and I only write 0, I'll assume that all the two scales start from 0. That means that the mark for the scale will be lost. But if you discriminate, indicate that for the y-x-axis, the first value is 47.5, and for the y-axis, the first value is 0. That particular scale is perfect and you're good to go. So do your plotting. That means that you'll score the marks for scale, plotting. If the curve is smooth, you score the mark for the curve, and there should be no problem there. So that particular part of the scale must be taken care of, because some students just ignore. I assume if there was no 0 and there was no 47.5, again, I'll just repeat that point. If there was no 0, there's no 47.5. The assumption is that the origin must be 0, 0. So again, you lose the marks there. So if the 0 again is not there and the 47.5 is there, in that particular case, I'll assume that all the values start from 47.5. So the scale mark will also be lost. So again, when you come to the reading, finding the quartile deviation, that means that you have to score the upper quartile, the lower quartile. So the scale that we use there will also be guide us in the interpretation. Like you can see that between 52.5 to 57.5, I've got 10 small squares. That means that for each small square, it will be 5 divided by 10, which is 0.5. Is that right? So that means that if I was to find the lower quartile, that will be a quarter of the total frequency, which is 10. You can see that after 57.5, there are 3 small squares. That would be 1.5. So when you add 1.5 to 57.5, the lower quartile becomes 59. And then the upper quartile that should be taken from the cumulative frequency of 30, it is exactly 1 square after 67.5. That means that the answer there becomes 68. And again, I will see that from this, we look at the smallest square that is given there, and the accuracy mark in that particular, on those readings will be subject to a plus or minus the smallest division on the scale that is given there. So from there, you can go ahead and find the other marks for the deviation, the quartile deviation, and the other marks that may be given from that particular area. Now, on trigonometric curves, in most cases, you'll be given a table that is already filled. The values that you're supposed to place or to fill in should be subject to the accuracy that is given the values that are already given there. Like for the table that I have there, you can see that the figures that are given there, they are rounded off correct to 2 decimal places. So if I was to fill any other value from there, if I was to fill the blank spaces, the values that I fill there must also be correct to 2 decimal places, not any other accuracy. That means that if you are to round them off, like if I was to find another 0.87, but I write 0.9, the B mark there will be lost because the accuracy has been lost from the values that you have given. So you must fill in the values depending on the values that are given on the table. So if it is 2 decimal places or 1 decimal place, all the answers that you give must also be to the accuracy that given on the values that are given on the table. So I'll go ahead and fill my values. Those are the values that were missing. So if I fill them, you can see that my answers again are correct 2 decimal places. You may ask for the 0.5 and for the 2. It may be condoned if it is 2.00. We may not be very strict on writing the 2.00. But the 0.87 cannot be 0.866 or cannot be 0.9. It must be 0.87. That is the key thing in scoring those marks for the table. And then again, you go ahead and do the plotting. The plotting again, I'll repeat that if you are given values or if you are given a particular scale to use, the scale must be used. If no scale is given, pick an appropriate scale that can accommodate all the values and plot your graphs. Now, a key question that comes from those curves is amplitude. Or before I go that, you can see the graphs that are given there. There's mark for the scale, mark for plotting. For these particular curves, they'll be plotting for each curve and the curve itself. So for the 3 cos x minus 2, it's plotting and look at all the values. If they are correctly plotted, you award the mark. If you draw the curve, you award the mark. Then for the second one, again for plotting and also for the curve. Now, if you look at the next one that is expected from there is you'll be told to use your graph to solve the equation. Maybe when 3 cos x minus 2 is equal to sine 2x. Again, you look at where the two curves intersect. Is that right? So as you read that, you look at the scale that is given. Between 0 and 30, we have got 5 small squares. That means that for each square, the degrees will be 6. So who can tell me the answer there? Where do those two curves intersect? I want to interpret the first intersection. It will be 20, 24, very good. And then if you go to the next intersection, just before 300, are you able to identify that mark? What will it be? 294. It will be 300 minus 6. But if you look at my curve, look at the curve between 270 and 300. And just before it, between 240 and 270. Is that curve perfect at that particular region? Look at between 270 and 300. It is bulging outward, is that right? Now, those are some of the few areas where if you meet a very strict examiner, you may not score the C mark for that particular curve. Now, that's why I was saying that if you've missed to score that C mark for the curve that is given there, then that that's why I was saying that if the examiner was very strict and denied me that C mark because of that particular area between 270 and 300, that means that the answer of the 296 that we have just read, even it was right, but that particular part of the graph was already condemned. The mark there will also be lost. But also varies from examiner to examiner. But the key thing is that you must make sure that your curve is as smooth as possible. So we were at the point we were talking about the curve, and we had mentioned that we're stressing on a particular area that the curve was not very smooth at. So that particular area you may get penalized. And we have said that in all graphs, when a particular part of the curve is condemned, the reading taken from there may not be considered to be the exact readings or will not be correct, even if they may be the correct values. So the values will be penalized because of the wrong the drawing. Like I indicated in this particular graph, between 270 and 300. Now, we indicated that the next question that may come from here is the amplitude. If I may ask, what is the amplitude of the first graph? Y is equal to 3 cos x minus 2. Who can tell the amplitude of y is equal to 3 cos x minus 2? What is its amplitude? The first curve. What is answer? 3. Okay. How about the first one? Y is equal to sine 2x. What is amplitude? 0. Amplitude of the first curve, y is equal to sine 2x. 1, because it goes up to a maximum of 1. Now, usually there's always confusion between when finding amplitudes. A student may look at the other curve and y is equals to 3 cos 2x, cos x minus 2. And look at the -5 and say that the amplitude is 5. Or the last one there is 4 point, is it 5 or 4 point something? 4.9, is that right? But I think it should go up to 5. Now, when you have such curves, it happened in 2016, where you're given y is equal to √3 something. Now, usually the amplitude is got from the coefficient of either cosine or sine. Like the first curve, it should be 3, the second curve should be 1. But when a student looks at the graph, he looks at -5 and he says that the amplitude is -5. You have to appreciate that that curve on the upper region it starts from +1. Is that right? So the simplest way to interpret that is that look at the average between 1 and -5. That is 6. Divided by 2 will give you 3. Because the graph does not start from 0. The one that starts from 0 is very clear, like the second one. It is 0 up to +1 and then -1. So from there you can easily pick. But if you were to get a confusion from that particular area, simply take the average between 1 and -5. And that will give us 6 divided by 2, which is equal to 3. Or better still, just pick the amplitude from the coefficient of cos x. That should be the answer of finding the amplitude. Now, let's look at several examples, few examples. If the curve is y sine 2x, like we have noticed in the first curve, amplitude will be 1 because the coefficient of sine is 1. Period is the coefficient of the angle. Like in that case, it was 2x. It is 360 divided by 2, which gives us 180. The second curve, we have y is equals to 3 cos x minus 2. The amplitude is 3, but the period, you take the coefficient of x, which is 1, you divide 360 divided by 1, which will give us 360 degrees. Now, if I'm given a curve of y is equals to 5/2 cos 3x minus 40, and then I'm asked to state the amplitude. Now, you'll notice that that amplitude, if you record it as 5/2 and leave your answer that way, you'll be awarded B0. Now, in mathematics, we don't leave our answers in improper fraction. Even if I was working, maybe finding area or working out a calculation on fractions, and the final answer is 5/2, or maybe 5, or maybe 7/3, you must leave it in terms of improper fraction, a mixed number, or as a decimal, if it gives you a terminating decimal. Like 5/2 gives us 2.5. That is acceptable, and 2.5 is also acceptable. Assume it was 7/3. The correct answer will be 2 1/3. If it was 7/3, the amplitude now becomes 2 1/3. Because if you are to write 7/3 as a decimal, you get 2.3333. Is that right? And that is not exact. So if the final answer does not give you a terminating decimal, this implies to all workings. You leave it as a mixed number. Now, period will be now 360 divided by coefficient of x, which is equals to 3. Is that right? That gives us 120 degrees. You can also be asked to find the phase angle. In that particular question, the phase angle is equals to the angle that comes after either the sign, the minus or the plus, which is equals to 40 degrees. Then you can also be asked to find the phase, phase angle, phase shift. There's a question like that, phase shift. How can I get phase shift from that inequality? The last one, y is equals to 5/2 cos 3x minus 40. Can you remember that? You take the phase angle, you divide by the coefficient of x. In that particular case, it will be 40 divided by 3. Sasa, that will give us the phase shift. So those are the areas that these should be free marks. Like I think last year there was a question on this. You are just given an equation like that. Y is equals 5/2 cos 3x minus 40. Then you have to find the amplitude, period, phase angle. Now, there are situations where a student, the question is stated, state the amplitude and period. but the student does not tell you which one is amplitude and period, but I can see 2.5 and 120, maybe separated with a comma. Now, what happens in that case, if the order of the arrangement in the question is amplitude, then period, and then you write 2.5, 120, you'll be awarded the 2 marks. But if the question is amplitude and period, but I see 120 first, or then 2.5, that means that now you have, because the order expected was should be amplitude then period, if you don't specify. So if you write 120 first, then 2.5, either horizontally or vertically, you'll be awarded B0, B0, because you have not specified which one is which. If you don't discriminate, that means that you're supposed to follow the order of the question. So if the order of the question was amplitude then period, and you don't tell me which is the amplitude, but I can see 2.5 first and then 120, there's no penalization there. You'll be awarded full marks. But it's always good to specify. But if in case you'd fail to, but you write the order, 2.5 first, then 120, no, in that particular case, you are awarded full marks. But if 120 comes first, then 2.5, you'll be awarded B0, B0. But I've mentioned that if the coefficient of cosine, like in this case, is a mixed or an improper fraction, you leave your answer either as a decimal if it is terminating, or a mixed number, but not as 5/2. Now, another area in trigonometry where students have challenges is when you're given an equation. This is a Form 3 work. I picked this just an example. Cos 2 theta plus 10 is equals to negative 0.5. The range is given from 360. 0 is less or equal to theta, or less or equal to 360 degrees. Now, if you look at the equation, the coefficient of theta is 2. That implies that the range that I'm given, I should also multiply it by 2. So the new range now becomes 0 is less or equal to 2 theta, which is less or equal to 720 degrees. That means that I'll go through a unit circle twice. Cycle 1 from 0 to 360, and cycle 2 from 360 to 720. Because the coefficient of theta in the equation is 2, and the question has got the range for theta only. And then there's always a confusion whether to find the cos inverse of negative 0.5 or 0.5. The negative there, we always advise that it only gives you a sign to know exactly which quadrant to find that angle. Cosine is negative in 2 quadrants. In which quadrants are cosine negative? In the second and the third, where we have S and T. But because the first and the fourth, cosine is positive. So go ahead and find the cos inverse of 0.5. But is it 60? Now, after doing that, I go to the second quadrant. The value of the second quadrant should now be 180 minus 60, which is 120. The third quadrant will be 180 plus 60, which will be 240. That is the first unit up to 360. Then the second round, in the place of 180, I'll now have 540. So the next value there will be 540 minus 60, which is for 80. And the third quadrant will be 540 plus 60, which will be 600. Then the next, when you go to 2 theta, when we now subtract 10 from all the values on the right-hand side, 2 theta becomes 110, 230, 470, and 590. Then that means the values of theta, now you divide every value by 2. So you get 4 answers. Theta will be 55, 115, 235, and 295. Now, the reason I picked this is because most students will, they will end up with only 2 answers, which will be 120 and 240, forgetting that if the range was given as theta is less or equal to 360, then the range that you are supposed to use should take the coefficient of theta in the question, which is 2. You multiply by 2, so that it goes up to 270 degrees. So that's the main reason I picked that particular area. And also to discriminate, the negative sign there of the 0.5 is just to show which quadrant you should be working from. If it was positive, I'll be working from the first quadrant and the fourth quadrant. But given that it's now negative, I work from the second and the third. So that should be applicable for all other questions on trigonometry. But if it was just theta, I'll go only one cycle. Then we'll move to the next. An area that is highly tested again in paper 2 is the constructions. It can either be circumscribing, inscribing, or ascribing, or loci. Always stamp them, they should be always be the free marks to students. Because, and again, this particular area, a mark is assigned for a particular activity. If you're asked to construct 60 degrees, there's a mark specifically for that 60 degrees. If you're asked to drop a perpendicular bisector from a particular point, there's a mark specifically for that. So for every task that you do in construction, a mark is always awarded. Now, try as much as possible to use a pencil in construction and graphs. If you are asked to use a ruler and a pair of compass only, please do. Because if you're supposed to construct an angle using a ruler and a pair of compass only, but you measure using a protractor, the B1 mark is lost. The readings or the measurements of the angle of the length should also be as accurate as possible. If you are to measure 2.5 centimeters or 5.3 centimeters, there's an allowance of 0.1. That means that it can be right. If it was 5.3, I'll actually measure if it is 5.4 right, if 5.2 right, but if the length is more than 5.4, that measurement will be penalized, will not be awarded any mark. The same applies to the angles. If the angle that was supposed to be constructed in 60 degrees, but you construct yours and I measure I get 62. Again, at 60, there's allowance for plus or minus 1. If I measure I get 59, very right. 61, very right. But 62 or 60 or 58, from that particular area, those will be penalized. And then some people will construct a triangle that is very complete, and then they fail to label. You're supposed to construct triangle ABC. You do it very well. You construct the angle, measure the length correctly. Angle, the mark is awarded. The length, the mark is awarded. But there's a mark for a complete diagram. If it's a triangle, there's a mark for that complete triangle. If it is not labeled, that mark will be penalized. You'll not be awarded that mark because you cannot see where A is, B is, and C is. Now, the good news is that if you continue, if there's any question after that, if you are supposed to, after to construct the triangle, you're supposed to bisect line BC. And I can clearly see from the measurement where your BC is, and you do that correctly. From that time onwards, you'll be awarded the marks. Will not penalize you any further because you are implying that you are now using the correct sides to do the further constructions. Or you're supposed to bisect a particular angle, and from your working, I can see that you have identified it correctly, then the rest of the marks will be awarded. You'll not be penalized for not labeling, up to the last point. It will only be for the complete triangle that was up there. But for the rest of the marks, we'll follow through and see if you're working the correct sides, and then the marks will be awarded. That is to be, you should not fear that because that is a very student-friendly type of marking. Now, I picked one that was set in 2017. It was inscribing a triangle. Inscribing and ascribing, there's always a problem. Like you are told that using a ruler and a pair of compass only, construct triangle LMN, in which LM is 5, LN is 5.6, and angle MLN is 45 degrees, 2 marks. Then construct a circle that touches all the sides of the triangle. What do you understand by the term that? Touches all the sides of the triangle. Which circle will that be? It will be an inscribed circle. Very good. And then we go ahead and do the question. So you'll notice that there's the first B1 mark is for angle NLM correctly constructed. It was supposed 45. I can see, you can observe that there's 90 degrees, first of all, constructed at L, then bisected to have the 45. The arcs are up there. The arcs must be visible. That is the evidence enough that you constructed that 45 degrees. So you awarded that 1 mark. If the arcs are missing, there'll be a problem there. Some students are very cheeky. They measure the 45 and then they place the arcs using freehand. I'll use a compass to verify that. But when marking a construction question, I measure. You have a ruler and a set and a compass, and I measure everything. Now, number 2, the complete triangle, A, B, C, D. L, M, and N, if it was correctly measured, the lengths were given. LM, the length that was given is correctly measured and placed there, MN and LN. And the marks are available. L, I can see L, M, and N. That will make the second B1 because the triangle is now complete. I can see the labelings and the lengths are also placed there. Now that B mark, if I forgot to write N up there, given that there are only 3 points and the only one that is missing is N, under you wear a human face and award the mark because that's the only mark that is missing. Is that right? But in case L, M, and N are all missing, but the trunk is very complete, the B1 mark there will be lost because I cannot tell which one was L, which one was M, and which one was N. That's why it is very important to label. Now, when you're inscribing, because you are told to draw a circle that touches all the sides, we are supposed to bisect any 2 angles. They have to be clear. You can see the bisector of angle NLM and bisector of angle NML. Visible. If that is done, you are awarded the next 1 mark. Now, the last 1 mark for inscribing is where students lose marks. They'll do trial from all the sides of the triangle, and then they get a very perfect circle that touches all the sides. But for you to inscribe a circle, you have to drop a perpendicular bisector from the center to any of the sides. So that last 1 mark should be tied. It is actually tied. The perpendicular bisector to any of the sides and the circle. If the circle is there, however perfect is it, but it is. And I'm not able to see the perpendicular bisector dropped from the center. That when I talk about the center, that is the point of intersection of the 2 bisectors. If I cannot see any perpendicular bisector from that point to any of the sides in an attempt to find the radius, that last 1 mark will be lost. And that is what always happens to students. They try and draw the circle. They do trial and error and draw the circle. A very perfect circle touches all the sides, but with the perpendicular bisector from the center to the side is not visible. If that is not visible, that last 1 mark will be lost because it is tied. Perpendicular bisector from the center to any of the sides and the circle correctly drawn. Now, if the perpendicular bisector was there and the circle misses one side, either there's a gap in between the inner part or there's the circle has overlapped to the outer part of the line, one of the lines. Again, that particular case, the B1 is lost. So these are not applicable for inscribing and inscribing. But for circumscribing, because circumscribing, you'll be told to draw a circle that touches the vertices. If you stand at the center and extend your compass to any of the vertices, already you have a point there that gives you a guideline of where the circumference should be. So in that particular case, it's not a must that you have a perpendicular bisector. But this one only applies to inscribing and inscribing, as we have seen there. Now, when you come to locus, I picked a question that was done in 2015. A locus is only complete when correctly constructed and labeled. If you read a question, you'll be told construct the locus of a point P. Like in this case, a point P equidistant from point A and B, and 4 centimeters from X. This is an example of intersecting loci. So point P, locus of point P equidistant from point A and B, you'll go ahead and bisect line AB, and it is visible there. Then 4 centimeters from point X, that is equidistance from a fixed point. You stand at X, measure 4 centimeters, and then you draw a circle. Those two loci intersect at 2 points. So you're supposed to label them. If you are to leave without the labels, you lose the 3rd mark. You'll get 1 mark for the perpendicular bisector, 1 mark for the circle drawn, but we have to see where do those points intersect. They intersect at those 2 points that I've labeled P1 and P2. Or you can even name both of them PP. So long as there is an indication, you have to indicate that those are the 2 points that you require. This will also apply if it was just a perpendicular bisector. It was just one loci. Locus of point P, equidistance from point A and B. Again, once I have the perpendicular bisector, I have to label it P. So that is the only trick about loci. If you construct it, you label it to make it complete. And then on the same area on construction, I picked this one because this was a 10-mark question. It can be a triangle, it can be a rhombus like we have, or a parallelogram like we have here. This was a rhombus. But initially you may be given an angle that you may not be able to construct. This one is 60, but assume you're given an angle of maybe 67.5. And you notice that I cannot construct 67.5. But if you look at the questions below it, you can easily solve them. Because the next question will be, after constructing the 67.5, you complete the rhombus. And you know that a rhombus, all the sides are equal. So it is a question you can do, but only one limiting factor. You cannot remember how to construct 67.5 or even 112.5 or even 75. Some people may have a problem constructing 75. Or even the simplest, which is 60, you may not be able to know how to construct. So the only limiting factor for you is the angle. And like we had noticed the first example, there's only one mark for that construction of the angle. Like the first question, we saw that there was only one mark for 45. The same will apply here. There's only one mark for that 60 degrees. And then when you measure line DC and BC correctly and draw them, you also awarded one mark. And then when you locate point C and complete the rhombus, you also award another one mark. But as like I had mentioned, that there's only limiting factor that you cannot remember how to construct the angle. This one should not be told to form 3s going downwards. But I'll tell you that measure that angle using a protractor. Because whatever you lose is just the one mark for the angle. Because this comes as a situation. That's the only question that looks favorable for you. You can do it. But you cannot remember that one element of constructing the angle. If you measure it using a protractor, you lose that mark for the construction. But when it comes to length BC and DC, if you do it correctly, you are awarded the mark. If you locate point C correctly, you are awarded the mark. That means that going forward, like the next question, if I was asked to bisect angle DASB, you have done it correctly. The 60 degrees that you measured up there does not affect what you are now doing in the preceding questions. So you have lost the one mark there, but the rest of the marks will be awarded, because we said that in construction, for every task that you are given, there's a mark awarded. There's a mark awarded for that particular question. Though it will make students become lazy. But the question is, if I was able to do it and lose that one mark and get the rest, at this particular hour that you need to score the marks, then I'd advise that you measure that angle if you cannot remember it. Go ahead and do the rest of the questions correctly. You'll be awarded marks for that particular diagram. So that's the reason why I picked this particular area. So that if you are not able to construct a particular angle, let it not limit you to do that particular question. If you can do the rest of the questions, measure that angle, the mark for the angle will be lost, but the rest of the construction, if you do it correctly, the marker will award you the marks. Though don't tell it to the form 3s. You'll make them become lazy. Form 3 going downwards. But if it's an exam situation and that is what I can do, I'll advise you that you measure that angle, lose the mark for the one mark, and go ahead and score the rest of the marks. Now, bearing. Also, mostly paper 1. Most students don't have a problem doing the rest of the question. The first part, all you need to do is that you are given a scale to use. The scale you give, if a scale is given, you must use it. Again, the angles must be correctly measured. In this particular bearing, we measure angles using a protractor. The protractor must be placed from the true north in the clockwise direction. Unless if you are given a compass bearing. Compass bearing can even start from the south. If you are told north 26 degrees west, that means that you start from south as you move westwards. But otherwise, the true bearing must start from the true north in the clockwise direction. Now, and again, if you're given a bearing answer in terms of a bearing, if it is a true bearing, it must be 3 significant figures. Now, the only problem that comes with the bearing is when you are answering the questions that come after it. I picked this particular question that was set in 2014. A plane leaves an airport L and flies on a bearing of 040 to an airstrip M, 500 kilometers away. The plane then flies on a bearing of 316 to an airstrip N. The bearing of N from L is 350 degrees. By scale drawing, determine the distance between the airstrips M and N. That particular question, you're not been given any scale to use, but you must pick a suitable scale that can accommodate all those values and they can fit into the space that is left in that particular area. Not too small, not too big. So if we decide to use a scale of 1 centimeter to represent 100 kilometers, that means that, and you can notice that at point L, I have a true north there. I've tried to circle it, the true north. Now, one thing you have to notice that you have to make sure is that your true norths must be parallel to one another. If you look at the points I've circled, the north at M and the north at L, find a way, find every way possible. The way we used to transfer parallel lines in Form 1. Make sure that those two nodes are parallel. That's the only way you can make sure that you have got the correct reading on any other question that will be asked from there. If they're not parallel to one another, you'll get wrong readings from the question that come after it. So you can, if you can make sure that you have the correct or the nodes parallel to one another, then you can be sure that if you draw the diagram correctly, the rest of the marks will be earned. Some people may ask that, is it a must to write the scale I've used? It's advisable to write it, but even if you don't write it, we can pick it from what measurements that you're having. But it's always advisable that you write, but it's not a must. But we can pick it from the values that you have. Because if it was 500 kilometers and I can see that LM you have 5 centimeters, I'll have assumed that you have used 1 to 100. How about if I write a scale, then I go and use another one? I commit and write 1 centimeter to represent 100 kilometers, but I go and use a different one. So if you have committed up there that this is the scale I'm using and go ahead and use a different one, there'll be a problem in the locations of those particular points. And then again, if you are asked to, like this case, you are asked to find the distance between M and N. This gentleman measured it and found it to be 6.8 centimeters. Go back and convert it to the scale that you used. Don't leave your answer at 6.8 centimeters. You multiply by 100 and have your answer at 680 kilometers. Most students always leave the answer as they measure. They measure MN and find at 6.8 and say MN is 6.8 centimeters. That was on the paper that you have, but the correct measurement should be converted back to the scale that was given. If it was 2 marks, I will give you 6.8 and deny you the other one. But it was 1 mark. I have to see the 680 for you to earn that particular mark. That is like in this particular case, it was M1A1. So the 6.8 will earn you 1 mark because it was 2 marks, and then the 680 will also earn you another 1 mark. But if it was only 1 mark, I have to see the 608. Now I'll repeat that if you're asked to find the bearing of a point, you are asked maybe the bearing of M from N. That means that I have to draw another north at N. And again, make sure that it's parallel to the north that you have at M and L. Then measure that angle using a protractor from the north pole, from the true north clockwise, and give your answer in 3 significant figures. Even if it was 10 degrees, you write 0, 1, 0 degrees. That is all on the bearing that I thought you should know. So again, it's another area where you can get most of the marks. And then another area that is highly tested in paper 2 is matrices and transformation. This is very wide, can be tested in paper 1 and paper 2. In paper 1, they highly test the transformations, the reflection, rotation, enlargement, But when it gets to paper 2, they mix it with the matrix or transformation. You're given a matrix. We already advise that if you have a matrix and points that are supposed to be mapped onto the object, all you need to do is remember the second president of Kenya, President Moi. M for the matrix, O for the object, I for the image. The matrix must come first, then the object, then the answer is got as the image. Then again, this is another area where students lose marks. Maybe sometimes they do it in a hurry. You plot the object and the image correctly, but you fail to label them. If you fail to label them, these ones are usually 1 mark. If you fail to label them, the B0, you get B0. And then in case of reflection, the mirror line should be clear. In case of rotation, the angle of rotation and the center of rotation should also be clear. And in case of enlargement, the center of enlargement must also be clear. Now, this particular area again, when you have the negative and positive values, sometimes you draw your graph in such a way that there's a particular image that will fall outside the space of the graph that you're given. Maybe you rotate and you find that the image falls. Maybe one coordinate of the image falls beyond the page that was indicated for the graph. So nothing should go outside the graph. As soon as you start drawing your axis, draw your axis in such a way that all the figures that you'll draw must fall within the graph that was given. If any part falls outside, that is straight away B0. Some people struggle. It falls outside and then start drawing the small squares to plot that particular point. It will be wasting your time and will not earn you any mark. So pick the axis such that all the values that you will plot will fall inside the graph. Usually the setter will have done the question and known that the point, all the points will be mapped onto the graph if the axes are drawn correctly. Now, in Form 2, usually there's no problem with the reflection and rotation and enlargement. The only problem comes in when you're asked to reflect. Now, I'll pick this one here. This one was, I think, 2015. You are given a quadrilateral and then you are given the coordinates of the object, LMN, KLMN. Then the matrix of transformation is 1. If you read row wise, 1, 3, 0, 1. And then it gives you K prime, L prime, M, N prime. Then you're asked to determine the coordinates of the image. So you have mentioned this particular case, the matrix comes first. Then, of course, you have the objects. In this particular case, you write the objects in column wise. Like K, which was 1, 1, becomes a column on its own. L, another column on its own, and up to N. Then you multiply. Multiplication of matrix should be row multiplied by column. You get the values of the image. This was awarded 3 marks. So that particular step there, you get M1, A1. But usually it's always 1 mark. You get 1 mark for that multiplication. Then you must go ahead and write the coordinates in horizontal column. The coordinates must always be horizontal. So if you stop at the first point, even if you had labeled K prime up there on top of 4, 1 as a column, and then M prime again, you label all of them, but the coordinates are not in terms of a column, or in terms of horizontal, in terms of a row, or appearing horizontally, like we have placed down there. There'll be no coordinates. Those are not now coordinates. The coordinates must come down there to in terms of rows. So if you don't do that, you lose that B1 mark there. If there are 2 marks, we'll be awarded the M1 up there and A1 on the lower side. But you fail to write them in terms of rows or in terms of the coordinate form that we have expressed down there, you also lose that particular mark. So the coordinates must always be given in terms of horizontal. We call it horizontal in terms of a row. Separated by a comma and enclosed in brackets. Sorry for that. So next, you are asked to plot. I've plotted my object and image. Again, after plotting the object and image, they have to be labeled. They may be not very clear, but I think you can see them. You must label them. If you fail to label, the B mark also goes away. You have to discriminate which one is the object and which is the image by labeling them. And then there's cases where you have successive transformations. Maybe matrix M followed by matrix N. Maybe M maps PQRS to P prime. And then after then, the P prime is mapped to P double prime by another matrix. So if you're asked to state or find one matrix that maps the original object, which was PQRS, to the final image, you just multiply the two matrices. But the order multiplication should be the second matrix, then multiplied by the first matrix. So the second matrix comes first, then you multiply by the first matrix. Then that single matrix that you get should be the matrix that multiplies or maps the original object to the final image. If you're asked to do the opposite, the matrix that will map the final image back to the original object, simply find the inverse of the matrix that got there. If you have to do that, you simply find the inverse. Though there's another option of using the coordinates. You find a matrix in terms of A, B, C, D, you enclose the object, then you write the coordinates of the image. Then you come up with simultaneous equations to solve them. But you can also use this one. If you want matrix that maps P double prime to PRS, simply find the inverse. Of course, you have to find the determinant first. The determinant will be should be negative 4. Not 4. Negative a quarter. Half times negative a half, that will be negative a quarter minus 0. So there's a mistake there. This will now be negative, then 1 over determinant. That becomes negative 4. Negative 4, this means that this becomes negative 2 up there. The upper one will be negative 2. Negative 2. And this becomes positive. Is that right? So that is the matrix that will map the final image back to the original object. So if you do that, you score full marks. Simply find the inverse of that particular matrix. Now, there's one reflection. I picked on this one because there's one reflection that always gives students a problem. Reflection on line y is equals to x or y is equals to negative x. The point when the object and the image, you cannot find it, the mirror line is not perpendicular to the object and the image. I'll pick that lower one. The P double prime, Q double prime, R double prime, S double prime. And then you have to reflect it on line y is equal to x. You'll excuse me, I've drawn it using a freehand. Otherwise, the mirror line should be drawn using a ruler. Students always struggle with the compass to construct perpendicular bisector from point P prime, P double prime to meet the mirror line. You do the same for all the points, then you take the measurements and transfer them because the object distance is the same as the image distance. Now, a simpler way of doing that, just count the number of squares. Like from P double prime, if you can trace that blue line, I'll count 2 squares. P from P double prime, 2 squares up to the mirror line. Then make sure that it's perpendicular going upwards. It means at 90 degrees, and also count 2 squares going upwards. You'll notice that P triple prime will now be up there. So 2 squares to the mirror line, 2 squares upwards. Do the same for Q. 1, 2, 3, 4. Q double prime, which should also be 4 squares up there. You just do the simple counting. You can count without drawing or you can just draw a dotted line. Do the same for R. For R, you will count how many squares? 1, 2, 3, 4, 5. Then make sure it's perpendicular to the mirror line. Also count 5 squares. 1, 2, 3, 4, 5. R double prime and lands up there. Do the same for S. From S, the mirror line. 1, 2, 3, 4, 5. But another perpendicular line. 1, 2, 3, 4, 5 should be up there. Slightly up at positive 1. Is that right? So it should go up to there, up to negative 1, 5 squares. Then at that particular point, you'll have got the image. It is faster, very accurate. You notice that when you use a compass, sometimes you find decimals. And then you try to approximate. Is that right? Actually, some students write decimals. But if you count, you get the exact measurement. And that formula is acceptable. So don't fear using it. Just count the number of squares and then, but for those particular mirror lines where the the mirror line is not perpendicular to the sides of the object. So instead of using a pair of compass, just count, and then you'll get your image. That will help you. Now, when you are asked to describe a transformation, for a rotation, if you have to describe a reflection, for a reflection, you have to state the mirror line. That means that you say reflection in line y is equal to negative y is equal to x, or reflection on the x-axis, or reflection on line y is equal to 0. That is when you fully describe a transformation. A reflection, you have to state the mirror line. You give the equation of the mirror line. For a rotation, you have to state the center and the angle. You say a rotation through 120 degrees, center 0, 0. Or a rotation through negative 90 degrees, center 1, 2. That is when a rotation is complete, when you have to describe. And we also know that when the angle is clockwise, is the answer negative or positive? A negative angle, is it clockwise or anti-clockwise? Clockwise. And when you measure anti-clockwise, the angle becomes positive. So there are terms that are used there. Positive quarter turn means positive 90. Negative quarter turn means negative 90. Is that right? Half turn will be through 180. Is that right? So usually half turn hakunanga negative na positive, because when you go through a half turn through 180, it can be negative or positive. They land at the same point. Is that right? Yeah. So when it's half turn, you just meet half turn. So it's 180 degrees. And then when you move to before we go out of that, rotation, sometimes you can be given the object and the image. There are questions where you meet, you are asked, you are given the coordinates of the object and the coordinates of the image. You are asked to state the center and find the angle of rotation. What to do in that case, like I have here x, y, z, and x prime, y prime, z prime. I can decide to join z to z prime and y to y prime. And then you bisect those two lines. Just use a pair of compass and bisect those two lines. The line joining z to z prime and y to y prime. Then where the two bisectors meet, in this particular case, you can see those two bisectors meet at, is it at 4, -1? Is that right? Now, at the point where they meet, that should give you the center of rotation. And then for you to find the angle of rotation, I've used the red pen there to join y to the center and then to y prime. But the object was y. So if I'm moving from y to y prime, am I moving clockwise or anti-clockwise? Look at that angle from y to y prime. Is it clockwise or anti-clockwise? The red patch, the red mark that I've placed there. It is clockwise. That means that when I measure that angle and get it as maybe 70, my answer should be -70. Is that right? So you state the angle and you have to locate, am I moving clockwise or anti-clockwise? So if it is clockwise, the angle becomes negative. If it is anti-clockwise, the angle becomes positive. And the center must be given in terms of a coordinate. In enlargement, you have to state the center of enlargement and also give a scale factor. You state the center and give the scale factor. You identify the center of enlargement and also identify the scale factor of enlargement. That is when the description for enlargement becomes complete. Another transformation that is highly tested in paper 2 is a shear. In a shear, you have to identify the invariant line. You notice that I'll show you in a bit. The invariant line is the point that does not, the line, the particular line where the coordinates do not change, do not move. Then you pick one point that is not on the variant line. You state its object and the image. If it's point A, you say that point A, which is 1, 0, is mapped onto point A prime, which is, I'll show you an example in the next slide. Like this one here, the one that we have just looked at in our previous. that matrix of transformation that you multiplied. That's an example of a shear. And you can look at, if you look at L, M prime and L prime, the points do not move along that particular axis. But N and M have moved. It was initially at 1, 3, and 2, 3. They have moved to 10, 3, and 11, 3. So if I were to state that matrix transformation, I say that this is a shear. The invariant line is the x-axis. And then I picked up a point M. Point M, which was 2, 3, has been mapped to M prime, which is equals to 11, 3. That is all. So you set the invariant line and a point on the invariant line that has moved. You state its object and the image. If it is a stretch, you have to give the invariant line again, and you give the scale factor of the stretch. The best way to identify the invariant line on a stretch, there's a particular axis where the object and the image intersect. Like you can see here, where I have where there's A, is it A prime? A prime and B prime, they intersect along the x-axis, along the y-axis. They intersect at along the x-axis, sorry, along the y-axis. So that particular case, I'll have identified the invariant line. Then the scale factor, you take the length of the image, you divide by the length of the object. The length of the image, you divide by the length of the object. Like in this case, if you notice that if you divide those two lengths, you'll find a scale factor of 2. Image distance over object distance gives you a scale factor of 2. So you say these are a stretch, y-axis invariant, scale factor 2. So a stretch is complete when it has a scale factor and the invariant line. Am I moving very fast? Now, there's an area of area approximation. I'll stress on one, the trapezium rule. This one, usually the formulas are on the mathematical table. There should be no problem using them. But there are sometimes that are used. Like in trapezium rule, we have, that is on the mathematical table. And sometimes you are told ordinates and strips. In trapezium rule, the number of ordinates are always higher than the strips by 1. But in mid-ordinate rule, because in each strip you find the middle of the ordinate. So actually the number of strips and the number of ordinates in mid-ordinate rule must be equal. If there are 6 ordinates, if there are 6 strips, that means that you use 6 ordinates because it will be the midpoint of each strip. But remember, the trapezium rule will use the lines. So they'll be higher by 1. So that should be the point that you are supposed to pick from. If you are told that there are 7 ordinates in the trapezium rule, that means the number of strips should be 6. Sasa. Now, in trapezium rule, there are usually 2 brackets. There's one I've highlighted in blue. That is the one that is always forgotten by the students. The one in blue. After half h, there's a bigger bracket, then you have y0, y6, then 2 into. Let me take you to an example of a working of a student so that you can exactly see what I mean. Now, that's a question that was sent in, I think, 2014. Completing the table, we said that up to there should be no problem, you get 2 marks. Then you are told to use trapezium rule with 10 strips to estimate the area bounded by the curve. The x, line x equals to -2, line x equals to 8, and the x-axis. Now, in that particular case, if you have been asked to use 10 strips, if the ordinates, you'll be told to use 11 ordinates. Is that right? Now, if we go to the working, or we'll fill the table. You'll score 2 marks for filling that table. That should be 3 marks for every student. Then to find the width or the height of each strip, we take 8 minus -2 divided by 10, the number of strips that we're told. We get a height of 1. I've done 2 workings. In blue, the student has said a half times x, sorry, half times 1, then there's that bracket, 16 plus 46. Of course, the y0 and y, in that particular case, will be y11. Then 2 into the middle ones, 2 into 10 plus the rest. For doing that substitution, you are awarded 1 mark, M1. Then if you do that calculation, 16 plus 46, you will get 62. Is that right? And 2 into 10 plus, you'll get, is it 200, 100 and what? 228. It will be 114, you multiply by 2, get 228. Is that right? Can you add that? 2 into, what do you get in the second bracket? 2 into? It is 228. 114 times 2, 228 plus 62, you get 290. Is that right? So half times 290. That means that the half should have multiplied everything that's on the bracket. So that you get half of 290 is equal to 45, 145. So you get M1 at the point 1, we have simplified everything in the bracket, you multiply by half times 290 M1, and then A1 at 145 square units. Student number 2 on the right has done the same thing, but has forgotten about the larger bracket, the bigger bracket. He has done a half times 1 times 16 plus 46 plus 2 into. The only thing that he has omitted is the outer bracket. The first 1 mark will not be awarded at that point. We have to wait and see that does he or she use the correct method, because at that particular point, that is not trapezium rule. The larger bracket that was outside there is still missing. So we wait and see how we are doing your working. At a half times 62 plus 228, again, at that particular point, we are not very sure that is that student still doing using trapezium rule, because if it is body mass, from there the answer should be 259. But if that student recovers and notices that I should add 62 plus 228, he remembers that in trapezium rule, we have to add everything first before multiply by half. He does that and get 145. All the 3 marks will be awarded at the last point, which will be M1, M1, A1. So that is how friendly the marking is. We wait and see that, are you going on with your work as expected? So wait and see the point at which you have proven that you have used the method. But if you use the bracket, the first substitution earns your mark. As you continue, earn your marks. But in this particular case, you still wait and see exactly what you are doing in the figures. So if you go ahead and use the figures correctly on the lower part and find the answer at 145, you are awarded only 3 marks at that particular point. The problem will be if you made a mistake there, instead of 145, you wrote 143, you lose everything. But if you are working there and you get 259, definitely that will be wrong. Is that right? So that bracket, that outer bracket in the trapezium rule is the key point where students lose marks. That's why I chose to pick on trapezium rule. Middle date, usually there's no problem. But middle date, you must make sure that you find the ordinates first, the middle ordinates. Now, there are questions that are set in paper 2, where you are expected to form a quadratic equation. And then it can be of length, sometimes it can be money. And usually in quadratic equations, we end up with 2 answers. Now, a student is working with the length, and then he gets 2 answers. One answer is negative, another one is positive. Then in his mind knows that length can never be negative. And then he also only writes 1 answer. If you write 1 answer, you get the correct method mark from working, but the A accuracy mark will be lost because you expected 2 answers, but you only indicated 1. It is obvious, yes, because you know that length can never be negative. But we expected 2 answers. So first of all, get those 2 answers. And then on the negative answer, you can try ignore. Or underline the positive answer. When you underline, that means you are picking on it. Or even you can circle it. If you circle it, you have identified that is your answer. Or better still, say the length is now this, you pick the positive one. But the 2 answers must be seen first. Yeah. So I picked on this one. This was, I think, in 2015. You are told in the length and width of a rectangular signboard are 3x plus 12 and x minus 4 respectively. If the diagonal is 200 centimeters, determine the area. If you make a sketch, you notice that the diagonal, you end up with a right angle triangle, so you can use Pythagoras theorem. So you apply 3x plus the square of the length, the square of the width, then you equate to the diagonal. That substitution gives you 1 mark because you have started applying the knowledge of Pythagoras theorem. That is the interesting thing about mathematics. Every step, applying a knowledge on a particular, applying your knowledge on what you are taught, you start earning your marks. That's why that particular instruction I told that you show you're working in every step. Now the second one may not award you, may not be awarded back because you're now doing expansion. But you can use any method now. You can use completing square method. You can use the quadratic formula. I chose to factorize. Now, at the point you have factorized, that shows that you know how to solve a quadratic equation. Again, you added 1 mark because you're using the wrong method. So you're using the right method to solve the quadratic equation. And then the point when you add, you go ahead and find the value of x is equal to 60 or negative 66.4. Of course, you get negative 66.4 when you get 5x plus 32 is equal to 0. When you divide, you get negative 66.4. You added an A1 mark. That is accuracy. Now, the last mark will be is B, simply because that one you can multiply using a calculator. Is that right? After getting the length, the x is 60. You can say 60 times 3 is 180 plus 12, 92. Then you multiply by 56. 1092 divided by, you multiply by 56. Then you get the area. But that student has done 1092 times 56 is equal to 10,752 centimeters. But I've awarded there B0. Who can tell me why? Yes? Very good. Oh, there's a no 1092. There's a is. Three times 60, 1800 plus 12. Oh, there's some problem working there. What is the answer for the length? 3x plus 12. 192. Thank you. So there's an error there. 192. Then when you multiply 192 by 56, 10? 10,752. The answer is right. Very good. Oh, even with that, I still write B0. Why do you think that B0 is there? Somebody had the right answer there. The units. Even though we say that in mathematics, the units are not important, but if you commit and write the unit that is wrong, the answer becomes 0. We expect that the area should be centimeters squared, but this student has gone ahead and written centimeters. So in that particular case, the answer becomes wrong. Now, this particular step where we have x minus 60 into 5x plus 332. If I forget about the 0, the m will be 0. Because at that particular point, I'm not proven to be solving a quadratic equation. That is now quadratic expression. Senior. So until I see the 0, that is the proof that you have factorized that equation completely. So if there was no 0 there, this m becomes 0. So I wait and see if you have solved it using if you have get it to 0, get 60 and 60.4. Then at that, the lower line now I add with M1 and A1. So in most cases, some students, they have a quadratic equation, but they work without the 0 up to the final point. So in that particular case, we wait until you get the final answers. That's where we award you. Because when there's no 0, that is now a quadratic expression. So remember that when looking at quadratic equations, you have to write the 0 is equal to 0 at the end. So if you ignore the zeros, we wait until because the only point now, if these two zeros were not there, this was, if I deleted these ones, there's no proof that I'm solving a quadratic equation. So I'll wait until when I see the 60 and the 66. That is why I'm convinced that you equated them to 0. At that particular point is when we awarded those 3 marks. Sasa. Yeah. that is a question on calculus. Usually two things are tested: how to integrate and how to differentiate. That is all. It can be in finding the area of area under curve. It can be a simple integration like what we have here. You need to remember that if there are no limits, you have to have the constant. If the constant is missing, the expression becomes wrong. Now, this question here, if the first, you look at that first step where you integrated x squared plus 2x minus 15, that process alone is showing that you know how to integrate. You added 1 mark. But if I failed to write these 2, 4, I think the 2, 4 on the stream right. If they are missing, I will be awarded M0. Or we'll still wait. It will not be M0 anyway. We'll wait to see that, do you know which limits are you using? So wait until you substitute them into the second one. Once we have seen 4 cubed over 3 plus 4 squared minus 15 to 4, then the other one. Then at that particular point, now we are convinced that we are now using the correct limits. So we'll have M1 in the second line. If the 4-2 was ignored up there, the 4-2 that on the extreme right on the bracket. So the M1 will be postponed until we see that you are substituting the correct formulas. And then you subtract and find the answer. Now, the reason I picked this, because some people are asking a question that, is it a must to leave answers in fractions when you are doing integration or you are doing trapezium rule or mid-ordinate rule? The answer will depend on the question that you are given. If the values were in decimals, definitely the answer will be in decimal. But number 2, if the question was testing your knowledge on how to use trapezium rule, which is an approximation, and then integration, which gives us the exact area. Now, if this was an answer from an integration question, which is 2 over 3, and then I write my answer as 0.667, I've done another approximation. Is that right? So that means that now I don't have the exact area. So that's why we say that that particular area, if you're getting the exact area to compare to an area that has approximated, if the area that the answer you end up with is not at a mating decimal, like we have here in 2 over 3, the answer should remain in fraction, because that is the only exact figure that you have. If you round it off, even if you force it even figures, it will be 0.6667, which is still another approximation, which is not the exact answer. So leave it in terms of decimal, so that because this now becomes the actual area. Sasa. So if you did using trapezium rule and you have got integration, you have an answer like 20 and a third. Let it remain as a fraction the way it is, so that when you're finding the percentage error in the calculation, take the exact, subtract the approximation, then you put over the exact. But don't round off this one again to recurring decimals or to maybe 0.667 as indicated there, because that will be another approximation on top of another approximation. The areas to be covered may be very wide and large. I've decided to focus on those particular few areas. There are areas I've left that like dealing with money, compound interest, simple interest, and appreciation, depreciation. Basically, if you have the formulas, I think there'll be not a very hard area to tackle. But because of time, we may end at that particular point unless anybody has a question. But what we have discussed in general, that when it comes to those particular areas, it will be helpful to use the formulas of those particular things. Now, the only area that I want to repeat is the area of binomial expansion that I was not able to put in a slide. But I can just mention something on it. Usually binomial expansion, you have the values on the mathematical table where you have the constants. So a student may be given a value to or an expression to expand. They go ahead with expansion and they forget about the constants. The making starts when we see the constants. When the constants are available is when we start marking that particular expansion. But if you go ahead and expand without the constants, it may not be of it may not give us the, you may not be able to earn the very first marks. If I may illustrate what I'm trying to say within a minute. And then you have seen that in commercial arithmetic, the questions keep on changing. If the test commercial income tax, the next is compound interest, hire purchase. So you should be good in those particular areas. I think there are very areas that don't give students most of the problems. Now, the area I was trying to mention is when I'm asked to expand, maybe x minus let's say 2 minus x, maybe raised to power 5. You have to expand that. Straight away, you go to mathematical table and look for the constants. That is what I should advise. Look for the constants of power 5. Do you have yours? Or you can use a calculator. Do you have to use a calculator to use find the constants? What are the constants? 1, 10, 5, 1. Now, if you have a negative sign, if you have a negative sign, if you have a negative sign, that implies that this will alternate from positive, this will be negative, and this will be positive, this will be negative, and this will also be positive, and the last will be negative. Now, this will be, the powers of 2 will decrease from 5 to 0. Is that right? This will be 2 power 4, 2 power 3, 2 power 2, and then 2 power 1, and 2 power 0. And then this will be x power 0, x power 1, x squared, x cubed, x power 4, and then x power 5. Now, at that particular point, you are already ripe for the first 1 mark, if it was 2 marks. But if you waited, if you had everything, but the constants are missing, the 5 is not there, the 1 is not there, the 10 is there. So the signs will be, this is still minus, this is plus. So there are students who do that, and they write the constant down here. 1, 5, 10, 10, 5, 1. Now, until you combine those, the expression up here and the constants, and have them in a single line, that is when you start earning the marks. So I'll advise that you insert the coefficients as soon as you start your expansion, so that you start earning your marks from the first expression. I think that is all I wanted to discuss for today. Unless anybody has a question, we can move from there. So maybe we can start from here. We can start from here. If you have a question, you can come and ask from this end. Anybody have a question?
You can just come
Mr. Malik?
in front of the laptop. And
Hello, Mr. Malik. Oh, that's right. Now the question is like the question is when you are writing a straight line equation, the coefficient of y, the last statement, should it be put in an improper fraction or a decimal?
Okay. If you have an equation or a straight line, y is equal to mx plus c. And maybe the constant is 17 over 4, for example. Should it be a mixed? So I've ended up with my y is equals to maybe negative 3x plus 17 over maybe 4. Maybe add 4y is equal to negative 12x maybe plus 17 as y is what? Huh? Plus 17. So I'm asked to leave my answer in terms of y is equal to mx plus c. So you go ahead and divide everything by 4. If I'm at that particular point, am I right or wrong? Or must I put this one as this will be 4 1/4? Or your question, is it a must? Now, that particular question is testing your knowledge. Can you express the equation in terms of y is equal to mx plus c? Our interest is just the format. So in that particular case, you can leave your answer as y is equal to negative 3x plus 17 over 4. But there's no harm if you go ahead and write as y is equal to negative 3x plus 4 1/4. Because the knowledge being tested there is, can you express your answer in terms of y is equal to mx plus c? So you're free to leave it as 17 over 4. You'll not be penalized for that. I saw a question from Kwandanze. So Kwandanze, you can go ahead and ask your question.
Let's say if you are in a mathematical question, which in a tied questions, which has parts A, B, and C, you get a wrong value at part A, and you substitute it to part B. Can you get a? Can it be a correct? You will get a wrong.
Thank you very much. That's a very good question. Now, if I was working a mathematical question, maybe I was given to find the volume. I go ahead and find the wrong volume. But the next question is density. I substitute it in finding, say, the correct mass that was given, and that my wrong volume that I had up there, and find the density. The only thing that you lose is the accuracy mark, because what you'll get there will not be the correct density that was expected. But you will be awarded the mark for using the correct method for finding the density, which is the correct substitution of the mass over the volume, but the accuracy mark will be lost because that is not the exact answer that you expected. So you will not be penalized for losing the part A in part B. Now, if I may add anything to that particular question, is that sometimes you have part questions, A, B, and C. Instead of doing, I do part B, I start answering part B in the space left for A. Even if it is right, it will be penalized because the instruction is do answer the question in the spaces provided under each question. So if you go ahead and answer part B in the space of A, it will be treated as a wrong working for that particular answer. So in that particular case, you will be penalized. You find that maybe a student has done the correct working for B in A. So in that particular case, you'll get penalized. But the first one that if you get a wrong value in A, but use it subsequently in B, you'll be awarded the marks for method will be right, but only lose the accuracy mark, which is for the answer. Are you answered? Now, there's a question from Muvuti Girls. Go ahead and answer. So go ahead and ask the question.
Question: when you are drawing an histogram, when do you use the frequency density or when we use the frequency alone?
Oh, thank you very much. Now, in a histogram, you apply the frequency density, which is the frequency over the class width. When the class widths are not uniform, there are points when you find the class widths. The class width become, maybe you have a class width of 10. And another place you have a class width of 5. Let me try to illustrate that. Maybe I have a class of 5 to 9. And then the next one is 10. 10 to 19. And then the other one is maybe 20 to 24. Now, and the frequency is given here. These are the frequency of maybe 6. These are frequency of maybe 2, and this is maybe 4. So if you look at the frequency, the class width of the first, what is the class width of the first class? Is it 4 or 5? It is 5. 10 to 19, 10, and 20, 24. So if I was to do a histogram in that particular case, I cannot plot the frequency against the class limits. So in that particular case, I'll go and do what I call frequency density. And the formula is you take the frequency, you divide by the class width. So like the first one, the frequency is 6, you divide by 5, you get 1.2. The next one is 2 divided by 10, 0.2. And the last will be 4 divided by 5, which will be 0.8. So in that particular case, I'll go and plot, but you cannot use the frequency. The values that you have here are very small. So that means that you can take the frequency density, you multiply by a particular constant. You can decide to multiply them by 10, so that I have 12 here, 2, and then 8. So that when I draw my scale, on the y-axis, I can use a scale of maybe 1 centimeter to represent 2. I'll get 2, 4, 6, 8, all the way up to 12. But on the class, these class limits, I'll have, this will be 4.5 to 9.5. And then from 9.5, this will be now be 2 squares. If 1 centimeter represents 5 here, this will be now be 2 squares. That means that I'll have, because the class width is 10, this will now be 19.5 will be here after 2 squares, and then 24.5. It has disappeared. Oh, the last one will be 24.5. So the first class will be a frequency of 12. If 12 was there, I'll draw my first bar. The next one will be 2. The second bar, those will be longer, and then the third bar will be 8. So that is the point when you use frequency density, when the class widths are not uniform. But otherwise, this is where we have frequency density against the class limits. But otherwise, when the class widths are uniform, you plot frequency against the class width, sorry, the class limits straight away. I hope you answered.
Yes.
Thank you. There's a question from Muvuti boys. Go ahead and ask the question. Muvuti boys. Yes. Go ahead.
Hapo Kitanga. My question is,
Yes.
When you are in the cumulative frequency, is it a must that you start the origin with the 0 always?
Okay. When you are drawing cumulative frequency curve.
Yes.
Okay. Now, when you are drawing a cumulative frequency curve, just like I wish I could take you back to the slide, but just like my first, the figure that the one that we have just used, like what we had, let's say we have 10 to 19, and then 20 to 29, and then maybe 30 to 39. And then we have the frequencies as 3, 5, maybe 2. We said that the first mark is awarded when you do the cumulative frequency. This will be 3, 8, and then 10. So I'll I'll specify if on the y-axis, I'll start from 0 and then you go to 2, maybe 4, 6, 8, and then 10. But on the x-axis, I have to specify that my graph is starting from the lower class limit of the first class, which is 9.5. And then you move to 19.5 and then 29.5. This was and then 39.5. So if the key point is here, I've discriminated that my y-axis starting from 0, but my x-axis starting from 9.5. Though I also mentioned that there are some students who do this, they put a break and then they start at 9.5, but we have to get that the y-axis starting from 0. So all are accepted. The only point that you should avoid is if the letter there is only 0. If the letter here is only 0, if I only put here 0, my assumption is that I've started from 0 for both the x and the y. So the scale mark will be 9 because for the x-axis, we have 0 to 19.5 for one square. That is 19.5, but between 19.5 to 29.5, there are 10 units for one square. So therefore, the scale mark there will be lost. But you should discriminate and indicate that on my x-axis, I'm starting from 9.5 and y-axis, I'm starting from 0. Again, if it is left blank, the assumption is that you're starting from the origin, so the scale will be lost. But otherwise, you're supposed to indicate, even putting a break may be not necessary. So long as you indicate that my y-axis starting from this particular mark, which is 9.5, and x starting from 0, you'll be awarded marks and you will be able to draw the cumulative frequency curve. I hope you answered. There's a question from Katelembo. Katelembo Center of Excellence.
Yes. My name is Chama. I have a question. When you
Be louder, please.
When you plotted your graph and on the bearing, when you plotted your points and you have not labeled them correctly. Let's say you have written like 5 centimeters instead of 5 kilometers. Will you be deducted marks for it?
Now, on bearing questions, our interest is to label the points. Like we had shown earlier, you have labeled point K, L, and M. The measurements that we are interested in are got from the scale. If you had decided my scale is 1 centimeter to represent 100 kilometers, and I've gone ahead and drawn the 5 centimeters correctly, but I've labeled at 5 kilometers, 500 kilometers, you'll not be penalized for that. All we do is that we measure the length. If the length is okay, there's allowance of plus or minus 0.1. If it is 5.1 or 4.9, it will be awarded. But our interest in bearing is the measurement of the line, not the labeling. The labeling is for the points. So you don't lose any mark by labeling 5 centimeters as 500 kilometers on a bearing.
And what about if you have done for a question, you have done the correct working and the answer you have lacked to write the good units? Do you lack a mark for the answer?
Oh, come again.
If you've done your question well and you have written the wrong units instead of the correct units, will you lack for the?
Oh, thank you. We showed that. I shown. Now I've done the correct working, the volume. I've got the correct answer, but I've written my answer centimeter squared. You only lose the accuracy mark because we said that in mathematics, we are interested in the value, but if you commit and write the wrong unit, the answer becomes wrong. The accuracy mark is lost. But the method will be correct. You only lose the accuracy mark because you have committed yourself by writing the wrong unit.
Okay, thank you.
Another question, please. My question is,
Janguli Memorial, you can go ahead and ask your question. Katelembo, mute your mic. Tanguli Memorial.
Okay, you have talked about amplitude and period in an equation. What about when you are given an equation like y is equals to sine 2x and you have been asked the phase angle of that equation?
If I got your question correctly, you say you have y is equal to
Y is equals to sine 2x.
oh, very good. And you have to find the amplitude of the period.
Yeah, the amplitude and the phase angle.
Or the phase angle. Now, this particular question, the amplitude, kindly mute your mic. The amplitude is the coefficient of the sine. Please mute your mic. The amplitude is the coefficient of the sine. In this case, it is 1. So amplitude will be 1. The period is, we said you take 360 divided by coefficient of x, which is 2. The angle becomes 180 degrees. But this particular question has got no phase angle. The phase angle is 0. For this particular question, the phase angle is 0. But if it was maybe 2x minus 10 degrees, then the phase angle becomes 10. But if it's just 2x, the phase angle is 0. There's a question from Chanda, secondary. Okay. Now we can do some questions for the next 11 minutes, and we will end there. Chanda, secondary. Chanda, go ahead and ask your question. Wandanze.
Now the question was like this: when you are drawing the curves of the equation of a straight line, and when you are solving the equations, the line you are solving extends the points of the curve. Will you be penalized for the line, or
Can you come up? Can you repeat the question? I'm not able to. I did hear it clearly.
the question is about the drawing the curves of a straight line, and you have not, the line you are solving the equation has extended the points of the curve. Will you be penalized for that?
Did you hear that? You are saying the maybe you can reframe it. The question is not very clear.
Now it's just like this. It is about the solving of equations of the curve. You draw a line and extend the points of the curve. Will you be penalized for the extension of the line, or you just extract the points of the x and give out?
Yeah.
Okay, I may not be in a position to answer that because like, you have done a straight line and it's extending the curve.
Yeah, and from the point, the line extends some points above the curve.
Okay, anyway, you only penalize when you are plotting a curve or a line, we only mark up to the last coordinate that was given in the question. Any point that goes beyond that, we don't really pay attention to. But if it was the extension was helping you solve a particular question in the preceding part, you can easily just read the extend the curve and read the particular values. If I got you right. But when you're making the curve, we only mark the plotting up to the point that was given. Chanda, you can go ahead and ask your question.
I have a
Chanda secondary, go ahead.
hello.
Oh, and you can unmute your mic and ask the question. K.C.S.E, I can see your mic is unmuted.
My name is Eunice Mwende. I have a question from trigonometry 1, form 2. The angle elevation of the top of a cliff from a point P is 45 degrees. From a point Q towards the foot of the cliff, the angle of elevation is 48. Calculate the height of the cliff. Excuse.
Oh, I'll answer your question, K.C.S.E. Maybe let's pick another question from more girls so that you can answer the questions all at once. More.
Hello. Hello.
Hi. I was asking.
Go ahead.
Hello, I'm Joseph from Chanda. I'm asking a question from binomial expansion. How do you go with this equation y minus x raised to the power 5? How do you get the value of x in binomial expansion? You are given a question y minus x is raised to power 5. How do you find the values of x and y?
Okay. Next question from K.C.S.E.
Excuse.
More girls.
Yes.
More
I was
girls.
asking. Yes. I was asking, assume you have done a method, then you're not sure, then you decide to do another method, still on the space provided. Will they choose the correct one or mark for you, or they will give you no mark?
Okay, I'll answer the question.
Then
Maybe you can answer those three.
The last one. You're given an image matrix, then and transformation matrix. How will you find the object matrix?
Okay. Let's answer those three questions, and then I think that maybe that is the last question that you're answering, so that we can.
Of visitors coming to see, so they will just answer about two more questions.
Now, I'll start with the question from was it K.C.S.E or K.C.S.E? But if I got you right, there's something like this. You have a cliff and you have 2 points, A, B, and then this is the foot of the cliff. Maybe the angle of elevation at point A, I don't know, the correct value you gave me, maybe 30, and here is 50 degrees. You are asked to find the height of the cliff. You just name that as x. But it's only possible if you are given that maybe between A and B there's a length. Let's say maybe between A and B is 10. So all you need to do is just identify a trigonometric ratio that can combine the two. That is tangent, adjacent, and hypotenuse. So you say that the tangent of 30 degrees is equals to h divided by 10 plus x. And the tan of 50 degrees will be equal to h divided by x. So at that particular point, I can write h in terms of tan 30. H will be equal to tan 30, which you can find the value from a calculator, and you multiply by 10 plus x. And then the same h can also be the same as x tan 30. So these are two equal values. Equate them and find the value of x. So you'll have tan 30 into x plus 10 is equal to x tan. This should be 50. This should be 50. So when you do that, you'll be able to find the value of x. And then from the value of x, you can easily find the height when you come back to the original question that you're having. I hope that is clear. The next question was from Chanda. If you are given y minus x and a binomial expansion, K.C.S.E, I hope I can wrap this one. I hope I'm not too fast. Y,
Yes.
I think y minus x power 5. Do the same thing, expand the normal way as we had said. 1, 5, 10, 10, 5, and then 1. Do the same thing. Minus, plus, minus, plus, minus. You do the expansion. This will be y power 5 x power 0. So you get the exact expansion. This will be y power 4 x power 1, y power 3 x squared, y power 2 x cubed, and then y power 1 x power 4, and y power 0 x power 5. So you'll have y power 5 minus 5yx, y power 4x, plus 10y cubed x squared, minus 10y squared x cubed, plus 5y x power 4, then minus x power 5. The only way this question is possible, you'll be asked, use your expansion to evaluate a value like 9.8 power 5. So you're asking how you find the values of x and y. That you'll find a way of writing 9.8 in terms of x and y. And 9.8 can be expressed as 10 minus 0. 10 minus 0.2 power 5. So that y will be 10 and x will be 0.2. That is the only way. And you'll be good to go. I hope you answered. And then the last question that I had from Mua Girls, you used the term image matrix and object matrix. Remember what we said in this particular topic? We said that you remember the president, former president, the late Mzee Moi. M for the matrix, O for the object, and I for the image. So if the object was missing and I have my matrix as 1, 2, 3, 4, then multiply by the object which is not there, I can have it as A, B, C, D is equals to the image that is given there, which is maybe 5, 6, maybe 7, 8. So go ahead and multiply and form a simultaneous equation. You'll multiply 1 by 2, 2 by B. You'll form a matrix, simultaneous equation. This will be A plus 2B is equals to 5. And then another one will be 2A plus 4B is equals to 6. You solve it simultaneously. You do the same for C and D, and you'll be able to find the coordinates of the object. With that, thank you so much for listening to me. It was a pleasure hosting you.